we're just going to run through what we discussed last time around. So we're just going to have a quick review of some of the key points that we took away from last time. Essentially, I'm just going to summarise what your homework should look like. Okay. They was like, great, I haven't done it. I'm joking.
You haven't read it?
No, I haven't. I've been away. I didn't want to read it. So we discussed why we breathe, right? And we breathe in air to bring oxygen into our bodies, which is obvious, right? We need that so our cells can survive. It's really straightforward. And oxygen is used in the presence of glycerol, fatty acids, amino acids, and what am I missing? No, so what do our cells use to make energy? Oh. Great start to the day. So we have oxygen molecules, fatty acids, glycerol, glucose, and one more. Amino acids? Okay. Yeah, so your cells use those to make energy, which is essential for our survival. Okay, so survival without oxygen. So the time a person can survive without oxygen varies on a number of factors: age, health, environment, etc. In general, brain damage can occur within a few minutes. Irreversible brain damage or death can occur around 10 to 15 minutes. Some of the data that I've looked at varies, but in general 10 to 15 minutes without oxygen. We discussed the misconception about carbon dioxide. Do you remember that? This idea that carbon dioxide is bad for us, which is untrue. Our blood, remember, which is simply a transportation system, it carries oxygen, but it also needs carbon dioxide to balance pH. Yeah? And if you remember that what we said last time, the reason carbon dioxide is also so important, because if we remember that our hemoglobin are like the taxis that transport and carry oxygen molecules in the bloodstream, it's carbon dioxide that gets these oxygen molecules off the hemoglobin. Oxygenated blood. This is in no order, by the way. These were just the random things I was going through that I remember that we discussed. Remember, oxygenated blood is blood with a higher concentration of oxygen relative to carbon dioxide. Deoxygenated blood has more carbon dioxide relative to oxygen. It's not, when I first started studying, however many years ago, I was completely ignorant and I thought the red on the diagram was oxygenated blood with an absence of carbon dioxide, and I thought the blue was carbon dioxide and no oxygen. Obviously that's not true, but that's just what a lot of people I've found assume when you don't know, right? So why do we need this system, this respiratory system? It's because, unlike simple-celled organisms, we need to bring oxygen into our bodies because we've created this surface, our skin, to protect us from the environment, which means that we can't bring oxygen in, which simple-celled organisms can. So you can think of our nose, our throat, our lungs, and our heart as a reflection of our evolution from these simple-celled organisms. So what are the parts of the respiratory system? We had our nose, we had our windpipe, we had our voice box, we've got our two lungs, left and right, we've got our bronchi, our bronchioles, and our alveoli. Yeah? And we try to look at breathing more scientifically. That means we wanted to be specific about what happens when we breathe. So our lungs don't inflate and then our diaphragm pushes down. It was our phrenic nerve which tells the diaphragm to contract, which pushes down, that allows these balloons, which are lungs, to inflate. Remember that? Yeah. Our heart is just a silly dumb pump. And if you remember how we try to understand the heart, I explained how it was very similar to me adding a pump into a bathroom to increase the pressure. So we wouldn't be able to get oxygen from our lungs to the distant parts of our body without a pump to increase that pressure. We remember that?
No.
And then came the slightly complicated part about how the heart operates and what it does. If we remember, it brings oxygen in through the nose, down the windpipe, into our lungs. Our lungs fill up, and then the furthest point, our alveoli, then transfer these oxygen molecules into our capillaries, and that enters the bloodstream. Yeah? Does anyone remember what the name of the main kind of pipe is that carries this oxygen-rich blood into the heart? No, that's out, the pulmonary vein. Yeah? Pulmonary vein that brings blood into the left atrium. And if you remember, that was at the top left or top right as we would look at it. Yeah? So it comes into the atrium, and then it bypasses a valve, a one-way valve, which was a mitral valve, and then enters the left ventricle. And if you can visualize it, that's the kind of main pump that pumps and pushes blood, oxygenated blood at high pressure through the aortic valve into the main aorta. And the main aorta has a descending part, which of course sends oxygen-rich blood to all the cells at the bottom of our body, and it also goes up. And there was 3 of those. That's what you generally see in the diagrams. The left subclavian artery, the left carotid artery, and the brachiocephalic artery. Do you remember those? We could see the 3, yeah? When we look at our notes for this afternoon, we'll have a look at the images again, and it might help a bit more. So then our cells receive this oxygen-rich blood, and as our cells pick up this oxygen, there's kind of a chemical waste product, and that is carbon dioxide. Yeah? Carbon dioxide then needs to get back into our lungs to be exhaled out into the atmosphere. And if we remember, it's collected at the bottom of our bodies by the inferior vena cava, and at the top by our superior vena cava. They enter the right atrium, that's it, past the tricuspid valve into the right ventricle, pushed out past the pulmonary valve into the pulmonary artery.
You can see that really nicely here.
And do we remember what the lub-dub sound was? The valves opening and closing, yeah. Oxygen requirement for the brain. The brain is highly oxygen dependent. How much as a percentage of oxygen does our brain need? It's around 20%. Even short-term oxygen deprivation can lead to cognitive impairment and in severe cases brain damage. On average, a person takes around 20,000 breaths per day. That's on average. Okay. Lung surface area, the total surface area of the lungs when flattened out is roughly the size of a tennis court. Breathing and heart rate are closely connected. So when you inhale, your heart rate tends to increase, which is sympathetic. When you exhale, it decreases, parasympathetic. Yeah, this is called the respiratory sinus arrhythmia. Do you remember briefly touching on that? Yeah, we'll look at that again in more detail in a moment when we look at this afternoon's slides. So the respiratory center is the brainstem. The brainstem contains the respiratory center that regulates the rhythm of breathing. It sends signals to the diaphragm and the intercostal muscles to control inhalation and exhalation. The Guinness World Record for holding one's breath underwater is over, any guesses? 24. Yeah. The facts tell me, however, such extreme feats are incredibly dangerous and are not recommended in case you think you want to break the record this afternoon. Nasal hairs are not just frustrating, they act as a natural filter, trapping dust, pollen and other particles before they enter our lungs. Coughing reflex. Coughing is a protective reflex. We know why, because it helps protect the airways. It expels irritants, mucus and foreign objects. We spoke about that when we looked at the tiny hair-like projections in our windpipe that are trying to clean the air as it comes in. So I didn't know this until I take Zaki swimming, but babies are born with a natural reflex called the diving reflex. When submerged in water, they instinctively hold their breath and slow down their heart rate. So they'd always say, no, he's fine, just put him, you know, just take him in. And I said, woman, I don't think you understand. I know, I have one job, is keep this little guy alive, and you're asking me to dunk him in the water. And I'd look around and all the mums would be just dunking, and Laura would just take Zaki and put him in. And I was like, I'm not doing it. And she tried to explain the anatomy to me, and I said, you can explain whatever you want, I'm not doing it. And then towards the end, once Zaki got more comfortable, even though he was a baby, I was just flinging him around in the water, and he was absolutely fine. But yeah, they do have this, this natural reflex, which us adults don't.